We're now going to continue on with Unit 3, now talking about Bohr models. So, like we were talking about before, prior to fall break, we did the history of the atom, talked about what different discoveries people made. Now, what do you guys remember? What was important about Niels Bohr's models? Write this down in your notes. So, if we can remember, he came around about 1913 with the solar system model by using different light experiments. And he started to determine that electrons move in numbered orbits around the nucleus, depending on their energy level. And the atoms were made from a positively charged substance with a negatively charged electron scattered about. So this was the model we were looking at, and it's kind of like the solar system, things orbiting something, or the sun in our solar system, but here are electrons orbiting the nucleus. So we today are going to learn how to draw these Bohr models, as they will help us later on in the year as we continue to make discoveries. So for our Bohr model, we will notice that electrons move in numbered orbits around the nucleus, similar to planets circling around the sun, just like we said. Orbits or energy levels are located at certain distances from the nucleus. So we have our first energy level, our second energy level, and our third energy level, and it increases energy throughout. So we call this N, or orbital 1, 2, and 3. Notice that different shells have a different number of electrons. So again, each of these blue dots represent an electron. So we have 2 here, yet on the second shell we have more than that. So take a second, spot some of the patterns you see in these models. So in your notes, what patterns do you notice? Pause the video. So hopefully we started to see that each of our first shells only contained 2 electrons, and then our second shells contained at least 7 or more electrons. We might notice that our protons are in the center, our neutrons are also in the center. We could also notice that we have the same number of protons and electrons, so these all must be neutral. You also might notice we found this information from the periodic table of elements. So I find potassium, it has 19 protons, 19 electrons, 20 neutrons. And maybe you even discovered more things after looking at these. I look forward to hearing what patterns you saw too. So now we're going to talk about how do we draw these Bohr models. So first, we need to identify the atomic number, the mass number, and the period. And we find that from the periodic table of elements. Next, of course, we see that the number of protons will equal our number of electrons and our atomic number. And then from there, we can determine how many neutrons we have. So our mass number minus our atomic number will give us our number of neutrons. Then we're going to need to figure out how many energy levels or orbitals, those shells, that we have. So the period number will actually tell us also how many shells we have. So again, our periods go across on the periodic table of elements and our groups go up and down. We will next draw all the energy levels, or the rings, around the nucleus and fill in the electrons from the inner core to the outer, or from the inner closest to the core. We will write the protons and the neutrons inside the first circle, which of course is our nucleus. So I know that was information overload. Stop the video and write down these steps if you haven't already. So like we said, each energy level has a different number of electrons. In this class, we will be using this table to help us. We will not go past 3 energy levels. Also, those would be very big Bohr models. But our first energy level will always have a maximum of 2 electrons. Our second energy level has a maximum of 8 electrons, and our third also 8 electrons. Each ring can hold less than the maximum number of electrons, but it can't. In this class, we won't see any that hold more than that. So again, our number of energy levels is the same as our period or our number of rings. So if we looked at this periodic table of elements, if I was drawing my electrons in my Bohr model for, say, helium, we only have one ring around the center ring because it's in period 1, versus 2 rings for period 2 if I was doing anything from lithium to neon, and then any element from sodium to argon will have 3 energy levels. So if we needed to draw a model for helium, I accidentally showed you the number of protons and neutrons already, but of course I would follow those steps. So first I need to figure out, it said identify the atomic number, the mass number, and the period. So I find helium, I find it has 2 protons, which is because that's the atomic number, and then the mass number is 4. Next, I can figure out how many neutrons it has. So 4 as my atomic number minus 2 for my number of protons will give me 2 neutrons. Next, it says draw all the energy levels. Well, since it's in the second group, I know it's going to have 2 energy levels, or 2 orbitals, 2 rings. And then I can draw all of them. Of course, I would draw them and then write the protons and neutrons inside the inner circle. So it would look like this. Again, I just had 1 ring, 2 electrons, 2 protons, 2 neutrons there. Now, if oxygen is next, I find oxygen on the periodic table of elements. I find that I identified the atomic number for oxygen is 8. Oh, I thought my pen was on. So my atomic number is 8. My mass number I see is 15.99 as the average atomic mass. So I'm going to round that to 16. And then the period, it is in the second period. So to figure out my number of neutrons, I'm going to do the mass number minus the atomic number. So 16 minus 8 would mean that it has 8 neutrons. And then my energy level, of course, it would be 2. Have 2 shells because it's in the second period. So I'm going to draw, of course, my nucleus. And then I'm going to have 2 energy levels. I might write my protons and neutrons in the center. And then I go from there. So my one for oxygen will look like this. I have 2 electrons in the first shell, and then my remaining 6 in the next shell. Take a minute, draw your model for aluminum by yourself. It should look like this. 13 electrons, you have them spread across 3 different shells. Notice that we first fill the shells closest to the nucleus, and then we go from there. So we have 2 electrons in the first shell, 8 in the next, and then 3 in the third shell. So we've talked about only Bohr models for neutral shells. Well, how would it change if it is a charged atom? If it is a positive charge, we know it loses electrons because we said our atomic number or number of protons cannot change. So then also if it's a negative charge, it will then gain electrons. So if I looked at oxygen, for example, I draw my original Bohr model, which would mean it would have to have 8 protons and 8 neutrons in the center, 8 electrons around. And then we said if it's a negative charge, it gains electrons. So this one's going to have to gain 2 electrons because it's a negative 2 charge. So then notice this one has 2 extra electrons. So instead of 8 electrons, I now have 10 electrons. So I still follow the same exact steps, but then I have to add or subtract electrons to show my ion, or my charged atom. Very similarly, if you have a positive charge, these are flipped, but I should draw the regular atom first. So this is just a traditional lithium Bohr atom or model. And then since it's a +1, I have to take one electron away. So notice it still has the same number of protons and neutrons in the center, but it has one less electron here. Practice some on your own, the next two examples you have, and then we'll go through the answers. So you should be doing He +1 and Cl -1. The answers for those next two are here, so hopefully you got those. If you did not get any of these practice questions right, make sure you put a star on them so that you can ask your teacher. Either send your teacher a message or an email or a message via Google Chat or via Google Classroom. And then at this point, please complete the rest of the practice problems in your notes, and that is your homework that will be due next class. So spend the next, until class is over, completing this activity. Thank you.